All right, couple quick reminders just to get back into it. If I am simplifying square roots, so that means I'm going to simplify this part. This part can't be simplified. I'm just going to bring it right here. I'm going to copy it because otherwise I'll forget that it's there. Then I'm going to focus on simplifying this part. So first I'm going to prime factor 18. 18 is 6 times 3. I could have also used 9 times 2. It doesn't matter. Okay, so my prime factorization of all of this is 3 times 2 times A times A times A times B times B times B times B. Now, I'm looking for doubles. The reason is, look, this is 3 squared, but then it's also being square rooted. So 3 squared and square rooted is just going to become 3, right? This is a single. It doesn't simplify like that. This is a double. This is A squared and then square rooted, right? It's squared. This is A squared. A times A, and then it's square rooted, so those are inverses, so this just becomes A. This is a single, it doesn't happen like that. This is B squared and square rooted, that becomes B, and this becomes another B, and then what's left inside is the pieces that don't simplify, so that's any single, so it's 2 and A. Okay, and then so I simplified this. I didn't quite write it correctly, right? I wouldn't write B times B like this. But now we're going to put it all together. And what I'm doing is this is staying the same. This 2A is staying the same. That's inside the square root. This can't be simplified. But I can multiply all this together. So 7 times 3 is 21. A times A is A squared. And B times B times B times B is B to the 4th. Okay, and if I don't have a number on the outside, right, then it's just less work. I don't have to do this last step of multiplying. Sometimes you only have a number on the inside or only variables, but you can treat it all the same like this. Let's remember solving equations with squares. Remember, when I'm solving an equation, my goal is always just to get x by itself. So my goal at the end is x equals a number. Now, what I need to do is just peel off one piece at a time, right? Right now, all this stuff is with x. I need to get rid of it. So I'm going to start by getting rid of this 3. And notice when I get rid of the 3, I'm bringing down everything else exactly as it is. Nothing is changing. The only thing that happened right here is I got rid of a 3. 77 plus 3 is 80. Now, this squared, it applies to these parentheses, but it doesn't apply to this 5. So I can't square root yet until I get rid of this 5. Okay, so I'm going to divide by 5. That 5 is being multiplied. Okay, and now this whole thing on this side of the equation is being squared. So now I can do the opposite of squared, which is square root. And if I do it on one side, I do it on the other. So I get x plus 6 equals. Now remember, when I square root 16, I'm asking myself, what multiplies by itself and equals 16? Now 4 times 4 is 16, but negative 4 times negative 4 is also 16. So I get 2 answers here. X plus 6 equals negative 4. X plus 6 equals positive 4. And then I'm going to go ahead and just solve. So I get x equals negative 10. I'm still just getting x by itself. I'm subtracting 6 from both sides, and x equals negative 2. You can write it as 2 separate answers like this, or you can write it as like x equals negative 10, comma, negative 2. Doesn't matter. I'm going to go right from here to here, just because these are kind of similar. This is solving again. So again, I'm looking to get x by itself. I notice that everything in here is square rooted. So I'm going to get rid of the 10 first, right? Because this is being square rooted, but the 10 is not. So I got to get rid of it. And notice again, the only thing that I'm canceling out here is the 10. 17 minus 10 is 7. And now everything here is being square rooted, so I can do the opposite of square root, which is squared. I'm going to square this side. If I square that side, I square this side. And 7 squared is 49. 7 times 7 is just 49. It's never negative 49 here. I'm just going to have one answer. And I'm done. Okay, so notice if I see squared in a problem, I'm going to end up square rooting it. And when I square root it, that's where I end up with 2 answers. A square root has a negative and a positive root. If I see a square root sign in a problem, I'm going to end up squaring it. And when I square a number, I actually just always get positive, right? No matter what I square, I get a positive number. If this is 7 times 7, it's 49. If it was negative 7 squared, it'd be negative 7 times negative 7. That would also be 49. But either way, I'm ending up with just one solution. Okay, last one. Estimating to the nearest tenth. So this is the square root of 35. It is not a whole number. If I put it in a calculator, it is ugly. It is a long, non-repeating decimal. Okay, so what we do is we sometimes simplify it like this, but we can also estimate. And I've just provided you a little tool down here. But when I'm estimating, I'm thinking, okay, the square root of 36 is 6, right? If I square root this number, I get 6. And if I square root this number, I get 5. So if I square root this number, a number just below 36, I'm going to get a square root that's just below 6. So what number is just below 6? Well, the number that's just below 6 would be between 5 and 6, but it's right next to 6. That would be 5.9. Okay, square root of 83. Square root of it, now if I square root 81, I get 9, right? If I were to square root 81, I would get the number 9. And if I were to square root 100, I would get 10. So the square root of 83 is going to be somewhere in between those two numbers, but 83 is definitely like way closer to 81 than to 100. Like it's actually like almost pretty much right next to 81. So I will call this 9.1. If you put 9.2, 9.1 is better. Okay, 110. If I'm square rooting 110, what am I going to get? Well, if I square root 100, I get 10. And if I square root 121, I get 11. So this, if I square root 110, it's going to be somewhere between 10 and 11, right? And in fact, 110 is like kind of right in the middle of 100 and 121. So what number is in between 10 and 11 and kind of like right in the middle? That would be 10.5. Okay, so feel free when you're estimating on your own to come back and kind of use this as a tool if that makes it easier for you.